Life is filled with fascinating tiny machines, mini versions of the everyday machines that we know. And just like every machine, we like to understand how they work to keep them running smoothly or to fix them if they break down. Behind me, you're looking at one example of the many machines inside each of us. This is a cartoon of a protein in our muscle cells. It acts like a tiny excavator, generating the pulling forces that leads to muscle contraction. This is how we can move and lift heavy stuff. Biology actually offers even more. Although I didn't show you today, there are other amazing tiny proteins inside each of us that works like a mini versions of wind turbine, copy machines, water pump, or even delivery trucks. They are life's essential machines, and they work like everyday motors. So can we use the physics of everyday motors to understand them? We know quite a lot about everyday motors. They're built with moving parts, like gears turn into cycles. They convert energy into actions. And their efficiency of doing that is limited by nature's tendency toward disorder. A physics principle known as the second law of thermodynamics. And it applies to all types of everyday motors. Now here's the twist. Biology's tiny machines, they aren't exactly like everyday motors. They work in cycles too, but they are soft and super tiny molecular machines that function in a much noisier environment. They're kind of like a drunken guy trying to finish laps, but under wildly shifting winds. Each lap represents certain tasks completed, yet along the way, he might take detours, slow down, or even backstep because of his intrinsic drunkenness and the chaotic forces around them. Traditional physics of everyday motor does not tackle this kind of drunken behavior in nanoscale machine. And that's where my research comes in. These biological machines, despite their randomness, they still follow statistical laws. So by analyzing the probability of each possible routes they can take in their cycles, I generalized the second law of thermodynamics to derive new physics principle that's applicable to all types of biological machines. These principles help us understand how they work, how well they perform, what's their fundamental limits, and how we might control and improve them. We're just beginning to read the manual of life's fascinating machines. And one day, we might even find new ways to treat diseases associated with their malfunctions, or even new ways to improve and upgrade these machines inside each of us. And that is the power for understanding life's essential machinery by shrinking the physics of everyday motor. Thank you.